Hi students, I wanted to kind of walk you through this next unit because this one can be kind of hard. So I want to kind of walk you through it as if you were sitting in the class and I was honestly teaching you guys in class, okay? Now you can either just not watch this and just do the Nearpod without even looking at this, or you can do this and then do the Nearpod after, okay? These are the exact same slides on that Nearpod, but I need you to complete the Nearpod either way because by answering those questions on the Nearpod, that's how I know that you completed the lesson. Okay, so let's go ahead and get started. So what I'm talking about is colligative properties. So colligative properties, this is, like it says, how solutes affect the solution. So for example, if I add salt to water, what does it do to the water? Does it change the properties of the water? Does the water have the same temperatures it requires to boil at or freeze at? And that's what we're talking about today. So, like it says, the learning objectives are to define what colligative properties are and then to explain the three ways solutes affect the solution. So there are three different ways we're going over that today. So let's first off define what colligative properties are. So colligative properties, these are when solutes, like some sort of salt, dissolve in solvents like water. The solvents actually have some property change. So when I dissolve salt in water, some of the properties of water actually change. And it changes in three different ways. So here's a little image right here. So just to remind you, solute is what you put into the solvent, and that makes a solution. Now, like I said, the water properties do change when I add salt to it. And this is actually one of the reasons we put salt on icy roads. So here are the three major effects of solutes. The first is it lowers the vapor pressure. And that is just me saying a fancy way of saying evaporating rate. So when I say lowers the vapor pressure, that's just saying it is slower to evaporate or harder to evaporate. Now, lowers the freezing point. That means it is harder to freeze. Water normally freezes at 0 degrees Celsius. When I add salt to water, that means water will freeze at -12 or -20 degrees Celsius. That it won't freeze at 0. It has to be even colder to freeze. Raises the boiling point. It means it's harder to boil. So water boils at 100 degrees Celsius. When I add salt to water, it will now boil instead at maybe 120 degrees Celsius or 140 degrees Celsius. So when I add salt to water, it makes it so water has to get even hotter to boil. Now, the big idea here is what determines colligative properties? Is it the type of salt? Does it always have to be NaCl, sodium chloride? Or could it be a different type of salt, magnesium chloride or potassium chloride? What type of salt makes water act so different? And the answer is, it does not depend on what salt you use. You can use magnesium chloride, sodium chloride, potassium chloride. You can use any salt you want. All that really matters is how much salt you use. So I know a lot of you like to put salt in your boiling water when you're cooking pasta. You put some salt in there. That salt is mainly for the taste because a little bit of salt you put in there is not enough to cause a big change in that water. If you dump like 2 cups of salt in a boiling pot of water, that would make the water have to be hotter to boil. But just a pinch of salt, that's not what we're talking about here. We're talking about a lot of solute, okay? But just to review real quick, it doesn't matter who I add, it matters how much I add. Okay, so the effect on vapor pressure, let's go over this one. So, like I said, vapor pressure is just a fancy way to say how quick will it evaporate and become a gas. So, the more solute in the solution, the harder it is to evaporate. So if I take two beakers and put them outside, one beaker has just plain old water, the other beaker has salt water in it. So a lot of salt in it. That water beaker will actually evaporate a lot faster than the salt water beaker. And can you think of why this would be beneficial? We have a ton of water on the earth, right? In the ocean. Is the ocean salt water? Would it be good that not all the ocean evaporates really quick? That'd be so sad for the fishes if they just all evaporate. Anyways, so adding salt or adding other like sugar or magnesium chloride, different stuff that dissolves in the water, it makes the water harder to evaporate or slower to evaporate. Now, why is this? Why is it that it's harder to evaporate? The main reason is I always think of like who's water hanging on to. So if I have my plain old beaker full of just water over here, that water is just hanging on to other waters, right? And they can break up, hang on to more other waters. It's fine. So they can easily evaporate, go back and forth. Whereas on my other beaker over here, I have salt water. Now, that salt, NaCl or magnesium chloride, any type of salt or sugar, when that dissolves in the water, the sodium separates from the chlorine. And waters surround the sodium, and then waters surround the chlorine. So these waters are super, super attracted to sodium and chlorine. They're hanging on to them so tight. So it's hard to separate out the sodium from the waters or the chlorine from the waters so they don't evaporate as much. That water's hanging on to the sodium chloride, so it's not going to let go and become a gas and evaporate. Whereas in my plain beaker full of water, it doesn't have anyone that it's super attracted to, so it can easily evaporate. So this is why when you add something to water, dissolve something in water, it is harder to evaporate. The water is hanging on to those things that you dissolve and doesn't want to be separated from it. Now, when you finish this lesson, I need you to go to the Nearpod lesson and complete these questions on there, these quiz questions, okay? Like I said, if you don't do that, then I won't know that you watched or completed the lesson and you won't get points. Now, the next one we're going to talk about is effect on freezing point. So the freezing point, this is when I once again add sugar or salt or something or dissolve something in water that it makes the water have to be even colder than normal to freeze. So like I said, if I had water that normally freezes at 0 degrees Celsius, when I add salt or sugar to it, the water will have to be even colder before it freezes. So maybe instead of 0, it has to hit -20 and then it freezes. And this is why we put salt on the roads during the winter time, because it says, hey, if you're gonna freeze, you gotta be super cold to freeze. So just real quick about this. A lot of students say weird things about this. When we place salt on roads, we do not melt the ice. So it's not very smart to place salt on already frozen things. When you place salt down, you should place it on liquid. So maybe it just was melting or something, or maybe it rained and that night's gonna freeze over. You want to put salt down when there's liquid, when it's wet, so that the liquid water will absorb the salt and then that prevents it from freezing at a normal temperature. So if you have like an ice patch on your yard and you put salt on that, it's really not going to do much. The salt does not melt ice. It just prevents water from freezing at 0 degrees. It makes it have to be even colder to freeze. Now, this is something that you usually have in cars as well. A lot of you are drivers and you put antifreeze in the car. Same thing. Antifreeze is this liquid that you put into cars to help the car kind of stay cold and not get super, super hot when it runs. Now, this liquid, right? If it's going to be 0 degrees outside, it's going to freeze in the car. And when liquid freezes, it expands and is going to burst your pipes. So we can't just put plain old water in your car to cool it down. We have to put like a sort of salt mixture in the car so that when you put your coolant in the car, it doesn't freeze at a normal temperature. It has to be even colder to freeze. And that just prevents your car from freezing over, which is awesome. Now, once again, go ahead and go to the Nearpod when you finish this and answer these questions. You need to do that to get points. Now, boiling point, this is the next one, and this is the next one and the last one. This is when the liquid is able to quickly become gas. I feel like a lot of you have experience with boiling. Also, I feel like you've done it in my class so far. But making pasta, making that kind of stuff, this is boiling point, okay? So when you add salt or sugar to a liquid, it makes it harder to boil. So what that means is if I turn my stove on and I have a big container of water and tons of salt in it, I'm going to have it get even hotter before it starts to boil. So instead of boiling at the normal 100 degrees Celsius, it has to get up to maybe 120, 140 before it starts boiling. Which is kind of crazy, right? But that's what dissolving sugars or salts or any solute does to water. It makes it have to get even hotter to boil. And the reason why is the same thing for the vaporization point. When you evaporate something, remember how it likes to hang on to the salts and sugars? That's why it doesn't evaporate as fast. Same thing with boiling. When I boil something and I have salt and sugar in it, it wants to hang on to that salt and sugar. So it won't boil as fast because it doesn't want to break up from that salt and sugar it's hanging on to. Now, like it says on this slide, the normal boiling point of water is 100 degrees Celsius or 212 Fahrenheit. Now, when you add salt to it, and like I said, not like a pinch of salt, a ton of salt, it makes the water have to be even hotter before it boils. Now, water can boil at different temperatures. So depending on the pressure of the water, it can boil at different temperatures. This is why higher elevations, like they always say, oh, Colorado, it takes forever to boil water. The higher your elevation, the more pressure on your water, the harder to boil. So if you went somewhere that's like sea level, you will boil water quickly. Less pressure, so the water will boil faster. Whereas here in Utah, we do have a pretty high elevation, so it does take some time to boil water. This graph kind of shows you the relationship between temperature and the vapor pressure. So it says when you get to a certain temperature, what vapor pressure is required for it to boil. And another application to your car is adding coolant to your car. If you look and see, coolant and antifreeze are the same thing. Why? Because they are both just a solution of salt and water. That's it. Now, antifreeze is normally a solution between water and something called ethylene glycol. Ethylene glycol is just something that dissolves in water that helps the car stay cool. So this coolant is in your car and it's meant to absorb the hot heat that your car is producing so their car doesn't overheat. If you ever drive past those people who have their cars and the gas flying off their car because the car is smoking, it's because the coolant did not do its job. The car overheated.